Okay, I had some questions about 6.8, and this is partial fractions. And these are questions that cannot be solved unless you use partial fractions. And the first thing you do is set it up to where you have A, B, or C over a common denominator or over parts of the common denominator. So this one has two denominators. It has 5x and it has 4x plus 3. So therefore we're going to have an A and a B because there's two denominators. So we're going to set it up as equals A over the first denominator, 5x, plus B over 4x plus 3. Now, whatever your denominators are, that's what you're going to set it up as. If there's three denominators, three different denominators, you'll have A plus B plus C. If you have a quadratic as one of the denominators, then you'll have it A plus B plus CX over plus B over whatever. We'll show you that one as the last one of the last questions I go over. This is pretty much the bottom of the barrel. It's pretty simple. It's just two denominators. The 5x is a denominator and the 4x plus 3 is a denominator. So we just put A over 5x and B over 4x plus 3. The next step is multiply by the common denominator. Well, the common denominator is this whole denominator right here. So I'm just going to multiply both sides. And I'm just going to put it on this side because I got more room. 5x times 4x plus 3 over 1. And that will knock this 5x plus 3 out, and that's what it will always do. So if you multiply by the correct common denominator, you'll always get the numerator on the left-hand side. And the right side, the 5x will cancel, and that leaves you with A times 4x plus 3. And 4x plus 3 will cancel, and it leaves you with B times 5x. Now actually, this part is pretty simple because you just set each one equal to 0, because if you want something to zero out, you have to have one of them equal. If this A cancels out, that leaves us with one variable and one equation. If we cancel that B out, that leaves us with A and an equation. So if we knock out one variable, then we have a quote solvable equation. So I'm going to let 5x equal 0. So I'm going to go over here and I'm going to say 5x is equal to 0, x is equal to 0. So if I plug in 0, this one will go out. But what will happen to the rest of it? Well, let's see. 9 is equal to A times 4 times 0 plus 3. And I'm going to go ahead and plug it in here so you'll see what will happen. B times 5 times 0. And of course you see that the B term cancels out, and that's what's supposed to happen. And now you're left with A, 9, is equal to A times 4 times 0 is 0 plus 3. That's 3. Sorry about that. And A is equal to 3. And I'm going to go over here and I'm going to put over here to the side A is equal to 3. Alright? Now once I do that part, I'm going to go back and erase all of that. So if you need to pause the video, pause it now so you can write down what I did. But I'm going to go ahead and erase it. Now I'm going to plug in 0 for the A part. I'm going to go, okay, well 4x plus 3 is equal to 0. 4x is equal to negative 3. X is equal to negative 3/4. Well, if x is equal to negative 3/4, I know if I plug negative 3/4, this term is going to go out. So 9 is equal to A times 4 times negative 3/4 plus 3 plus b times 5 times negative 3/4. And of course, the 4's cancel here, and that leaves you with negative 3 plus 3, which is 0 times a. That term goes out. And that's what's supposed to happen. And now you get, over here, we're going to go over here, and we're going to get 9 is equal to b times, well, that's negative 15/4, negative 15/4, and I'm going to divide by negative 15/4, divide by negative 15/4. When you divide a fraction or a number by a fraction, you multiply by the reciprocal. So negative 4 over 15 times 9 over 1 is equal to b, and 3 will go into 9 3 times, 3 will go in there 5 times, so that's equal to negative 12/5. Negative 12/5 is equal to b. And we're going to go over here, and we're going to write that over here. b is equal to negative 12/5. So we're done with the problem now. Pause it if you need to catch up with whatever I wrote down. But I'm going to erase this, and now we're going to finish the problem. We're done with the calculating. Okay, so I'm going to erase all this. We're done with the algebra. Now all we do is plug and chug. So our answer is 3, or a is 3, over 5x plus, and I'm going to put the 12 on the top and the negative on the bottom, or the negative, it doesn't matter because it's going to change this to a negative, but I'm just going to put it on the bottom. Negative 5 times 4x plus 3. And that negative, you can take it up here, you can bring it down here, but it's going to, either way, if it's up here or down here, if it was up here, it'd be negative 12 over positive 5. It's going to change this to a negative. So your answer, 3 over 5x minus 12 over 5 times 4x plus 3. And that is the factorization of this. Okay? So that's one type problem that you'll have. I had to write several type problems down because I wanted to cover all the different type problems that you're going to have in this section. Now I thought I had it on video, but evidently I don't, because I had 2 or 3 of y'all send me a text and let me know. The next one is 3x plus 6 over x plus 6, 6x minus 1. X plus 6, 6x minus 1. First thing, how many denominators do we have? We have 2 terms in the denominator. So you're going to use a and b. You're going to use a over x plus 6 plus b over 6x minus 1. Because you got 2 parts, you got 2 terms. So equals a over x plus 6 plus b over 6x minus 1. Multiply through by the common denominator. Well, the common denominator is the whole denominator. So I'm going to multiply the whole thing by this right here. X plus 6 times 6x minus 1 over 1. And what that does, it cancels the left-hand side, and you're left with the numerator, which is what's supposed to happen. 3x plus 6 is equal to, the x plus 6 is canceled, that leaves a times 6x minus 1 plus the 6x minus 1 is canceled, and that leaves you with b times x plus 6. Okay, now we go through and pick one. I'm going to pick 6x minus 1. So 6x minus 1 is equal to 0. 6x is equal to 1. X is equal to 1/6. Now instead of plugging that in to this one, we know it's going to zero out. I'm just going to plug it into this one and this one because I know this one zeroes out. So I'm going to cut out a step. So here we go. 3 times 1/6 plus 6 is equal to b times 1/6 plus 6. Okay? Because if I plug in 1/6 right here, I'm going to get 1 minus 1, which is 0. 0 times a is a, and it cancels out. So I'm just skipping a step there. All right? This becomes 3 over 6. So I got to get a common denominator. 36 over 6. Oops. Equals b times 1/6 plus 36 over 6. Now, in my years of teaching, this is where people have a meltdown. They go, where did 36 over 6 come from? You got to have a common denominator in order to add or subtract fractions. That's why people can't do algebra, because they never did learn how to do fractions. So I changed this 6. This is 6 over 1. I changed it into a 36 over 6. This is a 6 over 1. I changed it into 36 over 6. 1 will go into 6. 6 times 6 is 36. Okay? That'll give us 39 over 6 is equal to b times 37 over 6. Now, when you do the math, you get b is equal to 39 over 37. B is equal to 39 over 37. Now, I want you to go write that up here somewhere. B is equal to 39 over 37. And after you write it down, pause the video in case you need to check where I did something. Pause the video right now, and I'm going to erase this, and we're going to attack this one next. Okay? So I'm going to erase it. And I'm going to say x plus 6. I'm going to do it over here out of the way. X plus 6 is equal to 0. X is equal to negative 6. So if I plug in negative 6, this one will go away. So that'll leave this one. So we'll go ahead and plug in 3 times negative 6 plus 6 is equal to a times 6 times negative 6 minus 1. 3 times negative 6 is negative what? Negative 18 plus 6 is equal to a times negative 18 minus 1, which is negative 17. And that's going to be negative 12. Oh, I'm sorry, negative 6 right here. I knew something didn't smell right. There we go, negative 37. Negative 36, sorry. There we go. And this is going to be negative 12 is equal to a times negative 37. You do the math, you get a is equal to 12 over 37. And you write that over here. A is equal to 12 over 37. And now you're ready to plug and chug. So I'm going to take my eraser and I'm going to erase this. You need to pause it. And usually you can do this on your paper. It's just that I write big and I don't have enough room on here, and I had to switch screens, and that would kind of mess people up, so I just erase it as I go. All right, so now I plug it in. Now remember, that denominator is going to come down here with this denominator. So that's equal to 12 over 37 x plus 6 plus 39 over 37 6x minus 1. And that should be your answer there. Okay? So again, you have the first term, A over the first term, second term, B over the second term. Now the next problem I have, you have a trinomial. And you should have learned in algebra with your 101 and 102 teacher, a trinomial is worthless unless you what? Unless you factor it. Okay? And if you don't factor it, it ain't going to help you. So there it is. 3x. Oh, we just did that. Sorry. There we go. There's a trinomial. So this one is worthless. A trinomial is worthless usually unless you factor it. And that means factor it by reverse FOIL, or if you can factor it using, the quadratic formula, which I do not use, completing the square. But in this case, reverse FOIL is the correct way to do it. So, of course, that would be x plus 3 and x minus 6. So I'm just going to rewrite it. X over x plus 3, x minus 6. And we got, again, just like the last problem we did, we have two terms in the denominator, so you're going to use A and B. If there was 3 terms, it would be A plus B plus C, and you'd list each with 3 terms. So, A over what? X plus 3. Plus B over, that's the second term, x minus 6. Multiply through by the common denominator. The common denominator is this whole denominator right here. So that's basically going to cancel this out and leave what? The x, and that's what's supposed to happen. Equals, and I'm going to write back in black. Hey, ACDC, back in black. All right, x equals, and then x plus 3 is kind of canceled, and that leaves x minus 6. So A times x minus 6 plus B times x plus 3. Now, this by now you should be seeing the pattern. Okay, x minus 6 is equal to 0. X is equal to what? 6. If you plug 6 into this one, it's going to take that one out. So 6 is equal to B times 6 plus 3. Okay, that's 9. So divide by 9, and that's equal to B. That's 2/3. So B is equal to 2/3. So go over here and write that down. B is equal to 2/3. And if you missed what I did, this 6, x minus 6 is equal to 0. X is equal to 6. That's what I did. I did my algebra to find this, and then I plugged it in. If you plug it in here, it'll cause you 0, so you don't need that one. Okay? And that leaves B times 6 plus 3. Plug in the 6 here, plug in the 6 here, and you get 6/9, which is 2/3. Now do the 3, x plus 3. Well, that's -3. So if you plug in x is equal to -3, if you plug in -3 here, it's going to take that out. So that leaves you with just this area over here. So -3 is equal to A times -3 minus 6, that's -9, is equal to -3 and divide by -9, A is equal to 1/3. So that goes over here too. A is equal to 1/3. Now remember, when you have a denominator, when you got a fraction, this denominator is going to come down here with, it's going to come right here, and it's going to come right here. All right? So while I'm erasing the board, you go ahead and write the answer. Plug those in. So that's going to be 1/3 times x plus 3 plus 2/3 times x minus 6. And if you was to break this up, you would break it up into that right there. So here is your first twist. When you have a trinomial is worthless unless you what? You factor it using the reverse FOIL. You could use shortcut or reverse FOIL. Shortcuts 1 through 5, which I put those on videos way back in the review, I think. Here's one right here that, well, this is not a shortcut. This is where you actually have to divide. Because sometimes the degree of the, there we go. Look at here. Take my handy dandy highlighter. The degree is the same. If the degree of the numerator and the denominator are the same, you can use long division. Or if the degree of the numerator is more than the degree of the denominator, if this was an x cubed, or an x to the third, or x to the fourth, or x to the fifth, you could divide. So I got to use long division. So here we go. X squared plus 6x plus 9 divided into, and you got to put zeros wherever there isn't anything, plus 0x to the first plus 0x to the 0. Because this is x to the first and this is x to the 0. All right, so how many times will x squared go into x squared? Well, that's 1. 1 times x squared is x squared. 1 times 6x is 6x. 1 times 9x to the 0 is 9x to the 0. We always subtract in long division, so that makes this a negative, makes this a negative, and makes this a negative. And I don't know why that just did that. Some Russians, that's what it is. And, oh, Hubert, don't be sarcastic. And that'll be, that goes out, which is supposed to happen. And that'll leave you a negative 6x and a negative 9. So that's the remainder. So we got to rewrite this as this is 1, and I'm going to put a comma. You can put a plus if you want to, but I'm going to put a comma with the remainder is negative 6x minus 9 over x, and I'm just going to rewrite this as x plus 3 quantity squared, because that can be written using shortcut number 1. This can be written as x plus 3 quantity squared. Square root of that is x, square root of that is 3. So that can be written as that. Now, you've got part of this answer as a mixed fraction, as a partial fraction. So we need to do this partial fraction so we can finish writing our answer as far as how many times x squared will go into x squared. Okay, so we set it up. Now this is different because this is a what? This is a square in the denominator. Let me take my handy dandy Verde and see that right there? That's a square. So you've got 2 of them. You got x plus 3 times x plus 3. So that means we've got 2 things down here that's in motion. We've got an x plus, I'm going to erase my long division. We're going to set this up. When you've got a square, when you've got something that is raised to the second power on the bottom, and it's x plus 3 quantity squared. This is a quantity squared. When you have a quantity squared, you have to set it up like this. A over x plus 3 to the first power which is x plus 3, plus b over x plus 3 to the second power. Now what if this was x plus 3 to the third power? Then you do x plus 3 to the first power, x plus 3 to the second power, x plus 3 to the third power. You always go to the highest degree. So since this one has a degree of 2, we're going to go 1 and 2. And that's it. Just stop at 2, the second degree. Okay? Don't try to think about it too hard. Don't try to reinvent the wheel. Just do what I tell you on this. Okay? Trust me. All right, so now we multiply through by the common denominator. Well, when we multiply through by the common denominator, which is x plus 3 quantity squared over 1, that's going to knock this out, which is supposed to, and give you negative 6x minus 9, which that's supposed to happen, is equal to a times x plus 3, because 1 cancels with that 2, and that leaves the 1 power right here, and then plus b, because this cancels with this. So this is turning out to be a pretty simple problem. Okay? So I know this is negative 3. If I plug in a negative 3 right here, it's going to knock this out. So I'm going to plug negative 3 in right here. 6 times negative 3 minus 9 is equal to b. And that's going to be a positive what? 18? 18 minus 9 is 9, and that's b. b is equal to 9. So put that over here. b is equal to 9. Now, the good thing about this problem is when you have a variable by itself over here, and you find out that variable, then you can plug in any number for x and solve it. Okay? Write down what I just said. If you've got a variable over here by itself, b, there's no x's, there's no numbers, there's nothing, then you can plug this 9 in and plug in a simple number like 0 or 1 for this, and you can solve it. Because think about it. When I plug that 9 in right here, plug that 9 in right there, how many variables do we have? 1, just x. Okay? I'm sorry. We plug in 0 for x, plug in 0 for x, or 1, either one. We'll plug in 0. How many numbers do we have? How many variables do we have? We have one equation, one unknown. So if I plug in 9 right here, which we found the answer, I'm just going to do it over here. So that's going to be negative 6 times 0 minus 9 is equal to a times 0 plus 3 plus 9. I could plug in 1, I could plug in 2, I could plug in 597 and 1/2 on both sides. 597 and 1/2, 597 and 1/2. I could plug in 1,000 right here. I could plug in 1,000 right here. As long as you know what b is, and b is by itself, you can plug in any number for x and still get the answer for a. Okay? So, 0 minus 9 is negative 9. A times 3 plus 9. Minus 9 is negative 18. Negative 18 divided by 3 is negative 6 is equal to a. Write that over here. Write that over there where negative 6 is equal to a. Oh Lord, I forgot to turn my page over. Yeah, negative 6 is equal to a right here. A is equal to negative 6. Now you can plug and chug. So I'm going to skip a step. I'm just going to erase this right here. And I'm going to plug in, since we have whole numbers, I'm going to take my handy dandy green for day marker. And I'm going to make negative 6 go right here. And positive 9 go right here. And I'm going to circle this right here. That is our answer. So far we went over 3 type questions. We went over one that had several terms in the denominator. Several terms in denominator. Second one, we had a trinomial in the denominator. And we factored. Third one, we had, and this is one that we have right here, we have a trinomial, but we also have long division. Long division, and in the second part of the long division, we had a degree, a second degree, we had a quantity squared in the denominator. I'm just going to put x plus 3, quantity squared in the denominator, in denominator, which means that we have to change it to x plus 3 to the first power and x plus 3 to the second power. And if that would have been a third power, we'd have x plus 3 to the 1, x plus 3 to the 2, x plus 3 to the 3. So you got to watch these because you got to remember to do that. And the last type problem that I saw in the homework is the one where you have actually, and this one's going to take a little bit of work, so you might want to put it on top of the page by itself. There we go. Okay, this one, you have a quadratic down here, x squared plus 4. Now, you have a 2 here. You have something raised to the second power here, so you're going to have to x to the first, x to the second. So you got three terms on the bottom of this one. Okay? So that means you got to, and this is a quadratic. Okay, you cannot factor it. Put factor and then put an x through it. You can't factor x squared plus 4. And that's why you have to learn your what you can factor and what you can't. So when you can't factor a quadratic, you have to put cx plus d or dx plus e or whatever on the top of it. Depends on how many terms you got in front of it. We've got 2 terms in front of it. Right here, 2. X to the first and x to the second, because this is a quantity to the second power, so you have to include both of them. So a is going to be over x to the first, plus b over x to the second, plus, and then we're going to use the new one, since it's a quadratic that cannot be factored, cx plus d, it's supposed to be a capital, sorry, cx plus d over x squared plus 4. Now what if we had another term down there? We had x squared minus 3. We have x squared minus 3, then it would be dx or ex plus f over x squared minus 3. You would keep on going. Okay? So now we're going to multiply through by the common denominator, which is the whole thing over there, which will knock the left-hand side out. So I'm going to multiply both sides by this guy right here. And that's going to give us, I'm going to put it over here, x squared times x squared plus 4 over 1. And that's going to knock this out. And that's going to leave us with our numerator, which it should, always. And that's going to equal, and you might need to write small on this one because it's going to get, we got to do some tedious stuff here. All right, that's going to leave x1, we'll cancel this one out and leave an x to the first in this. So that's going to be a times x times that x squared plus 4. Okay? This x squared will cancel with this x squared and leave this, so that's going to be plus b times x squared plus 4. And what's going to cancel here? That x squared plus 4, and it's going to leave x squared times cx plus d. Now the first thing I would suggest you do at this point is go ahead and distribute all those terms in front of the parentheses. Write that down in your notes. You want to, at this point, you want to use the distributive law next. Okay? So I'm going to take my handy dandy blue marker and I'm going to just draw an arrow here, here, and here. And if you have to, put your little 1 there and put your x to the 0 here so you can just do what you need to do. It depends on It depends on how good of an algebra student you are. So 5 is equal to ax to the third plus 4ax plus bx squared plus 4b plus cx to the third plus dx squared. Now, whenever you use the distributive law, usually in mathematics, algebra, the next step is to combine like terms, and that's what you're going to do now. So I'm going to take my handy dandy highlighter, and I'm going to use dang old aqua. And we're going to, okay, first one I read from left to right, I need a cube. Is there any more cubes? Ding, here we go. There we go. So I'm going to put those two together. 5 is equal to ax cubed plus cx cubed. All right, next one is 4ax. Nothing. Plus 4ax. And I'm just going to take a highlighter yellow, and I'm just going to highlight that one, meaning that we've done it. Okay, you can mark through them if you have to, like you cross them out. Bx squared. Is there another x squared anywhere? Yes, there's another x squared. Let me take my handy dandy green verde. There's a bx squared, and we've got a what? A dx squared. So we'll put them together. And a lot of people say, how can you put those together? Well, what's 2 plus 3? Same as 3 plus 2. It doesn't matter if you put it here or if you put it over here. You're going to add them, they're going to be the same thing. Plus bx squared. And the last thing is 4b, and you just bring it down because it can't do anything. There. Now, when you combine like terms, the next step after you combine like terms is factor out a common term. Don't pronounce that out loud. Okay, so what's in common with the ax cubed plus cx cubed? X cubed, that's right. But I'm going to write it a little bit different, okay? I'm going to write it like this. 5 is equal to a plus c, and I'm going to put parentheses around it, and then I'm going to put x cubed. The reason that is because, you remember the quadratic form equation? I'm just going to go up here and write it. 0 is equal to ax squared plus bx plus c. You remember that? That's a coefficient, that's a coefficient, and that's a coefficient. That's x to the 0, and that's x to the 1. But what if I had x to the third? Well, you could do that. 0 is equal to, I'm just going to make up a ax cubed plus bx squared plus cx to the first, and this is a coefficient, this is a coefficient, and this is a coefficient. Well, it's going to help when we solve it here in just a minute. It's going to help us to know that this is a coefficient in front of this x cubed. And just trust me, okay? Plus, what else is in common? Well, I'm going to take my highlighter, my Verde highlighter, and I want to, there's our commons right there, and our common in aqua. I'm doing this for y'all. I do so many things for y'all. There's our common there. So really, we've got two things that are in common, and I'm going to take that second one, and I'm going to do the same as I did with the first one. I'm going to rewrite it as b plus d times x squared. And then I'm just going to say plus 4ax plus 4b. Okay, now at this point, we've done basically part one. Okay, we've got it down to this. This is what you want. You want something equal to ax cubed plus bx squared plus whatever x plus whatever. I mean, you want some kind of formation. Now what I'm going to do is I'm going to make this small. So pause it if you need to pause it to catch up. But I'm going to make it small here in just a second, if I can. Just try this. Hopefully I can make this happen. I think that'll work. Okay. All right, now watch what I do here, because you've got to think out of the box here, because I'm going to make this side look like this side. 0x to the third plus 0x squared plus 0x plus 5x to the 0 is equal to a plus c to the third x to the third plus b plus d x to the second plus 4a x to the first plus 4b x to the 0. Now, watch what I do here. I'm just going to use a different set of colors here. I'm going to take my orange highlighter, and I'm going to highlight, oops, wrong one, sorry. I'm going to highlight this guy. I'm going to just start from the right-hand side and highlight this guy. All right, since those two variables have the same exponent, I can set them equal to each other, right? So I'm going to go down here, and I'm going to say, okay, 5x to the 0 is equal to 4b to the x to the 0. Now, since these two are the same variables, I can say that this coefficient is equal to this coefficient. Okay, that's what I was showing you up here. Okay, all right, so that means that this coefficient is equal to this coefficient, so I can say 5 is equal to 4b. Now, it's very important that you understand this, because this is what you use in these type problems. You have to set these. Like the orange equals orange. Let me go right here, show you this. Even though it's not going to help you very much, it will in a few minutes. Let me do magenta. Okay, x to the first. Well, x to the first is equal to that. So we'll set that equal to 0x to the first is equal to 4a x to the first. So therefore 0 is equal to 4a. Therefore a is equal to 0. You get it? So we'll do that next. All right. But first I want to take that orange highlighter, and I want to highlight this. And since those two are equal, then this and this is equal. So B is equal to 5/4. B is equal to 5/4. So you go over here and you write that down. B is equal to 5/4. Okay? Now you can erase this if you want to. I'm going to erase it because I want to concentrate on one thing at a time, because this is the most difficult problem that's in there, and one of the most. So I'm going to take my eraser and I'm going to erase this, and I'm also going to erase what I just did. So I'm going to erase here, and I'm going to erase here. All right, the next one. The next one is 0x is equal to, 0x to the first power, sorry, is equal to 4a x to the first power. Take my magenta now. and highlight that 1. So since the x to the first is equal to x to the first, then that means that these two coefficients are equal to each other. So 4a is equal to 0 divided by 4 divided by 4. A is equal to what? 0. Write that down. A is equal to 0. Okay, now we can erase that. So I'm going to take my handy dandy eraser and I'm going to erase that. I'm going to erase that and this. And then I'm going to erase this. Okay, now what? Well, let's do the squares, Hubert. Okay, we'll do the squares. And I'm going to take my highlighter. And I'm going to use, I don't like to use red, but we're going to use it. There's a 2. And there's a 2. Now I'm going to skip a step here. And I'm going to say this coefficient is equal to this coefficient. So 0 is equal to, I hate it when it does that. I don't know why it does it. So I'll say it's the Russians. That's what it is. 0 is equal, this 0 right here is equal to b plus d. Well, Hubert, how are we going to solve that? That's two equations, that's two unknowns, one equation. Well, what do we have for b? 5/4. So 0 is equal to 5/4 plus d. Therefore, d is equal to negative 5/4. Put that up here. D is equal to negative 5/4. And erase that. And of course, you're going to see, we're going to solve for C now, but you're going to see that 0 is going to come out to be 0. C is going to come out to be 0 because 0 is equal to A plus C. Well, what is A? A is 0, so C is equal to 0. So by default, you can just go over here and say C is equal to 0. And you can go ahead and plug it in if you want to. We'll go ahead and do that. 0 is equal to A plus C. And A is equal to 0. Therefore, C is equal to 0. Now, what did we do when we had we just plug them in. So I'm going to do my eraser, and I'm going to erase this right here. And I'm also going to erase all of this, because all we're going to do after we've done all the work is plug and chug. Really not even in chugging, we're just plugging. So here we go. Here is our final answer. Equals, what's A? 0 over x. Well, we're going to fill in everything so everybody can see what's going on. 5/4 over x squared plus C 0 x plus negative 5/4 over x squared plus 4. And what happens to 0 over A? That goes out, and you're left with 5. Please stop that. You're left with 5 over 4x squared. Remember, if you have a fraction up here, that basically comes down. 5 over 4x squared plus negative 5 over 4. Hold on. Five times x squared plus 4. And the only thing is this is going to make this a negative. So 5 over 4x squared minus 5 over, 4. It's supposed to be a 4. 4 times x squared plus 4. And that is basically the 4 or 5 type problems that you're going to be dealing with in 6.8. So I hope that helps, and continue to text me or email me if you see anything else you need to go over.